quadratic equation. A quadratic equation is in the form ax squared plus or minus bx plus or minus c, or for a constant, equal to 0. So that's by definition what a quadratic equation is. Now, the highest exponent, whatever it may be, tells you the number of answers you should have. So normally our highest exponent with being quadratic is an exponent of 2. So that usually means we get 2 answers. Now, the first thing from lesson 26 I want to go over with y'all is something that you've seen before, known as the square root property. We used the square root property in one of the Pythagorean theorem problems. So let me go over the general property with y'all. If you have x squared, or it could be any letter squared, equal to some number or some constant, in order to solve for x, or solve for, get rid of the exponent, you do the opposite of squaring something. So the opposite of squaring something is taking the square root of both sides. That's what we're going to do here. Take the square root of both sides.
Look, that turns it off. That turns it on, and it flashed on there for a minute, but
Warner Robins, did y'all make it okay?
I think this is for this.
So what we'll do to both sides is take the square root, and the root and the exponent actually cancel each other out. So you're just left with the letter by itself. And anytime you take the square root of a number, you're going to have a plus and a minus in front of your square root, or in front of your number. Hang on just a second for me. Warner Robins, can y'all see and hear me?
I guess.
Hang on just a second, other campuses. Let's make sure, want to make sure that Warner Robins is with us. Hold on just a second, y'all. Hey, Diane, this is Morgan. How are you? I'm doing well. Can you do me a huge favor, please? Room 238, can you make sure everything is cut on? I see one of my students was trying. I don't know if she got the TV and everything on. Okay, thank you so much. Bye-bye. Warner Robins, can you see and hear me okay? other campuses, just hang tight for just a second. Want to make sure Warner Robins is on board. And while we're waiting, I'll put this example up on the screen.
Mr. Arnold,
Yeah.
are you discussing Warner Robins now?
I can hear you.
You can hear us, okay. They can hear you now, and they can see you've got lesson 26 up. Is that correct?
Yes, ma'am.
All right, I think they're set up now.
Awesome. Thank you, Ms. Rutherford.
You're welcome. Have a good day, Mr. Arnold.
You too. Okay, we got Warner Robins on board. Discussing the square root property. And when you take the square root of a number, you're going to have two answers. You're going to have a plus whatever the number is and a minus whatever the number is. So, for example, if you had the square root of 9, well, normally that would be just positive 3. But also the square root of 9 is equal to negative 3. And let me show you why we get two answers. If you square 3, that's equal to 3 times 3, or just 9. And if you square negative 3, well, that's negative 3 times negative 3, which is also a positive 9. So with the square root, whatever the highest exponent is, that tells you how many answers you should end up with. Let's look at an example in which we are solving a quadratic equation by the square root property. We have in parentheses x plus 3 quantity squared equal to 25. And we want to solve for x. The first step is to get rid of the exponent. So the opposite of squaring something is taking the square root of it. Whatever we do to one side of the equation, we got to do the same thing to the other side. So we will take the square root of both sides. Now the root and the exponent cancel each other out. And we're left with just x plus 3. Don't forget, when you take the square root of a number, you have to put a plus and a minus in front of it. So the square root of 25 is plus or minus 5. Now we're almost finished. To finish solving for x, we need to subtract 3 from both sides. So we have x is equal to negative 3 plus or minus 5. Now, anytime you're left with just plain old numbers, then you have to split your answer and get your split your solution and get your two answers. So one potential answer is x is equal to negative 3 minus 5, or just negative 8. And our second answer is negative 3 plus 5, which is a positive 2. My math lab wants you to write your answers as a whole solution set. The order does not matter. So our solution set is 2 and -8. Any questions from any of the campuses or even off-site?
Why did the 3 go before the 5? Like, I don't understand why they weren't combined, or like why there's no 2 or anything.
Oh, good question. Anytime you got a plus minus symbol, or if you have like a square root or something in front, then you put your number, whatever number that you're transferring, put it in front. But actually, you could have written it that way also and gotten the same correct answer. You would still split it into 2 different answers. A -5 minus 3 and a +5 minus 3.
You're doing both sides. Okay.
Yeah, so really, that's a good question that you asked. Actually, you could put the -3 behind your number.
Okay, thank you.
You're welcome. Let's look at another example. This one also involving the square root property. We have in parentheses 5x minus 4 squared equal to 27. And we need to solve for x. The first step, get rid of the exponent. And to get rid of the squared, the opposite of squaring something is taking the square root. So we will take the square root of both sides. On the left-hand side, the root 2 cancels with the exponent 2. And we're just left with 5x minus 4. Now, 27 is not a perfect square root, but one of its factors is. So we can break down 27 as, and don't forget your plus minus, we can break it down as 9 times 3. Because we know the square root of 9 is equal to 3, so we'll pull a 3 on the outside, and there's a 3 left on the inside of the radical. Now we have a few more steps in order to solve for x. The next step is add 4 to both sides. So we have 5x equal to 4 plus or minus 3 on the square root of 3. And there's nothing you can do to the right-hand side because they're not like terms. The 4 does not have a radical or root 3 with it, so we can't combine anything on the right side. The last step is divide both sides by 5. And if you left your answer like this, I would actually give you full credit. Anytime you have a radical left over or an imaginary part, then you don't have to split it into 2 different answers. You can actually leave your answer as one whole fraction. But if you were to split this into two separate answers, you would have 4, in no particular order, 4 minus 3 on the square root of 3 over 5, and also 4 plus 3 on the square root of 3 over 5. And our highest exponent was 2, and that tells us we should have 2 answers, which we got. Any questions about the square root property? So far, our answers have been real numbers, but what if you get an imaginary part? So let's look at an example in which that happens. So question 3, we have in parentheses x plus 4 quantity squared equal to negative 36. Excuse me. Using the square root property, we need to get rid of the exponent. Again, think opposites. The opposite of squaring something is taking the square root of it. So we will take the square root of both sides. On the left side, our root and our exponent cancel, leaving us with just x plus 4. Anytime you take the square root of any number, whether it's positive or negative inside the radical, you have to put a plus minus symbol in front. Now, the square root of negative 36, we can break it down as follows. Break it down as 36 times negative 1. Because we know the square root of 36 is 6. And the square root of negative 1, remember that's defined to be I, or the imaginary part. Now the final step to isolate x, subtract 4 from both sides. So our final answer is x is equal to negative 4 plus or minus 6i. And I'll accept this answer with the plus minus symbol, or you can separate it into two different answers, namely negative 4 minus 6i and negative 4 plus 6i. Any questions about using the square root property? Now, what if you are trying to solve a quadratic equation and you can't use the square root property just yet? There's another method you can use to help you get it in the square root property form, where you can solve and get rid of the exponent. And that is completing the square. So let me go over the steps here. The first step, move your constant term or just your number to the right-hand side. The next step, make sure that the leading number in front of the x squared is a positive 1. So those are the two main things so far that you need to do. Move your constant to the right side if it's not already there by itself. And your leading number in front of your x squared must be a positive 1. If it's not a positive 1, then I'll show you guys in another example later how to deal with something that where the leading number is not a positive 1. The next step, take half of your middle term or middle number and then square it. So whatever the middle term is, or usually the number that's in front of your x, that's what you take half of and then square it. And the last primary step, whatever you squared, add it to both sides of your equation. Now, these steps are going to make much more sense once we have some numbers to play with, but these are the main steps in order to do what's called completing the square. Let's look at an example. And your letter can be, it don't have to be, doesn't have to be X all the time. It could be any letter that you're trying to solve for. Now the directions are complete the trinomial so that it is a perfect square. And then actually factor the trinomial. These are the steps that you perform to completing the square. Our leading number in front of the b squared is a positive 1, so we don't have to do anything extra. The first step is take half of your middle term. So half of 40 is 20. And the next step, whatever you got in the first step by taking half of the middle number, you take that number and square it. So 20 squared is equal to 20 times 20, or 400. So that number would make the trinomial complete. B squared plus 40b plus 200. 400, excuse me. Now, this is known as a perfect square trinomial because our number 400 is a perfect square root. So all you do here to factor is draw your two parentheses. What goes in the first two spots is how you break down b squared. So that's just b times b. And what goes in the last two spots is the square root of 400. So we just saw earlier that's 20. Now, because there are two of the same binomials, we can write this as one exponent. So we can write this as b plus 20 quantity squared. So this is part of the completing the square process, just to kind of show you what all to do on the left side. Any questions before we actually solve a problem? All right, let's look at this example. We have the quadratic equation x squared plus 6x minus 2 equal to 0. And we need to solve this quadratic equation by completing the square. By the way, this is still lesson 26 that we're doing. Well, the leading number in front of the x squared is a positive 1, so we don't need to do anything extra. We do need to move the negative 2 to the right-hand side, so we'll add 2 to both sides first. So we have x squared plus 6x, and leave yourself a little bit of room behind that 6x equal to positive 2. Now we're ready to complete the square. So step 1, take half of your middle number. So half of 6 is equal to 3. And to complete the square, square the number that you took half of. So we will square 3. And that gives us 9. Now, what we do with that 9 to complete the square, we add 9 to the left-hand side. And you guys know whatever you do to one side of the equation, you got to do the same thing to the other side. So we have to add 9 to the right-hand side as well. The good thing about completing the square is on the left side, you are left with a perfect square trinomial that you can factor. So we'll draw 2 parentheses on the left side. And what goes in the last 2 spots is the square root of 9. So we have a 3 in both of the last 2 spots. Now, because we have a repeating binomial, we can write these 2 binomials as one big binomial with an exponent. And because we got 2 of them, we can write this with an exponent of 2. Now, before we use the square root property to solve for x, did any campus have any questions? Now we can use the square root property to get rid of the exponent. The opposite of squaring something is taking the square root. So we will take the square root of both sides of our equation. Now the root and the exponent on the left side cancel, leaving us with just x plus 3. And don't forget, when you take the square root of any number, whether it's a positive or a negative under the radical, you have to put a plus minus in front. Why the plus minus sign? That guarantees, according to the highest exponent, that guarantees we'll end up with two answers. Now, 18 is not a perfect square root, but we can break it down as 9 times 2. And the square root of 9 we can pull out as 3. And the 2 stays inside the radical. One last step to get x by itself. Subtract 3 from both sides. So we have x is equal to negative 3 plus or minus 3 on the square root of 2. Again, if you have a radical in your answer or an imaginary or odd part, then you can leave it as this combined answer. You don't have to split it up into 2 separate answers. Any questions about the first problem? All right, let's look at another example in which you have to solve a quadratic equation first by completing the square and then by the square root property at the end. All right, the next question we have x squared plus 9x minus 22 equal to 0. Now, if you can factor a quadratic equation the normal way by drawing your 2 parentheses, then try that first. If you can't factor the regular way, you can use another method. Well, our leading coefficient is 1, so we don't have to change it or divide anything out. The only thing we need to do to start off is add 22 to both sides. So we have x squared plus 9x, and save yourself a little room behind the 9x. And that's equal to a positive 22. Now we're ready to complete the square. Step 1, take half of your middle number. So not every middle number is going to be evenly divisible by 2. So when we take half of 9, That's still just 9 over 2. The next step to complete the square is square 9 over 2. In other words, we're multiplying 9 over 2 times itself. So 9 times 9 is 81. And 2 squared, or 2 times 2, is equal to 4. Now, that last number that we got, the 81 over 4, that's what we add to both sides of the equation. Now, on the right-hand side, let's simplify that before we deal with the left side. In order to combine these two numbers together, they must contain the same common denominator. So what we can do is rewrite 22 as 88 over 4. Again, I didn't change 22, I just rewrote it to where it had the same denominator as our other fraction. So on the left-hand side, that gives us 169 over 4. Does anybody have any questions up to this point? Now, the left-hand side, although it does not look like a perfect square trinomial, it actually is one. So we can draw our two parentheses. And it's actually pretty easy to factor. What goes in the last two steps, the last two spaces, is the square root of 81 over 4. So the square root of 81 is a positive 9. And the square root of 4 is 2. Because we have the same binomial, we can write this as one binomial. Since there are two of them, we can write this with an exponent of 2. Now we're ready to use the square root property. As y'all know, to use the square root property, you need to eliminate the exponent of 2 by taking the square root of both sides. On the left side, the root and the exponent cancel, leaving us with just x plus 9 halves. And on the right-hand side, don't forget to put your plus minus before you take care of the radical. And fortunately, both numbers in our radical, under our radical, are perfect square roots. So the square root of 169 is 13. And the square root of 4 is 2. I want to make sure, are there any questions before we finish up this problem? Now we need to get x by itself, so we will subtract 9 over 2 from both sides. And I'll just move it up here so we can see it a little better. Now, because you have the same common denominator, we can write this answer as one big fraction. So when we write this as one big fraction up here, we have x is equal to -9 plus or minus 13 all over 2. Now, because all we're left with are numbers, there are no radicals or imaginary parts, we need to split this and get our two answers. So one answer is -9 minus 13 over 2. And the second answer is -9 plus 13 over 2. Our first answer, when we simplify, will have -22 over 2, which is -11. And when we simplify our second fraction, we get 4 over 2, or just 2. So -11 and +2 is our solution set. Again, any questions about completing the square or using the square root property? So far, each example has had a leading coefficient of +1, so we haven't had to do anything extra until now. So let's look at the next problem. Well, the first step is to move the -1 to the right-hand side by adding 1 to both sides. So we have now 2x squared plus 18x equal to 1. Now, we can't complete the square just yet, because in order to complete the square, this leading number, leading coefficient, must be a +1. So to get it to be a +1, just divide the entire equation by 2. Including the right side. So we now have x squared plus 9x equal to 1/2. Now we can complete the square. So the first step, we'll take half of the middle term. So half of 9 is just still 9 over 2. And the next step is to square the 9 over 2. And we saw earlier that was 81 over 4. That 81 over 4 is what you add to both sides of your equation. On the right side, we need to combine those fractions. And we already know that 4 is your least common denominator, so we need to rewrite 1/2 as something over 4. So we can rewrite 1/2 as 2 over 4. And that will simplify to 83 over 4 on the right side. Back on the left side, we have a perfect square trinomial. And how I know that is all we have there are perfect square roots. So let's draw 2 parentheses. And what goes in the last 2 spots is the square root of 81 over 4. So we saw earlier the square root of 81 is 9. And the square root of 4 is equal to 2. When completing the square, you should end up with the same binomial in each parentheses. So that way you can rewrite it with an exponent of 2. Now, before we use the square root property, did any campus or anybody off-site have any questions? Now, using the square root property to get rid of the exponent of 2, we do the opposite of squaring by taking the square root of both sides. Again, on the left side, the root and the exponent cancel, leaving us with just x plus 9 over 2. And don't forget, when you take the square root of any number, whether it's positive or negative, you must have a plus minus in front of it. Now, the square root of 83 we can't do anything with, but we know the square root of 4 is 2. Now, the last step to get x by itself, subtract 9 over 2 from both sides. And because on the right side we have the same denominator, we can write our answer as one big fraction. So our solution set is negative 9 plus or minus the square root of 83 all over 2. Any questions about completing the square or using the square root property from lesson 26? There is another way that you can solve a quadratic equation, and me personally, I'm not a big fan. I hate to say that, well, I don't hate to say this, but I'm not a big fan of the completing the square. There is another way that you can solve a quadratic equation, and that's by using what's called the quadratic formula. In order to use the quadratic formula, Your quadratic equation must be in standard form. In other words, everything must be on one side and 0 on the other side. So your quadratic equation must be in standard form in order to use the quadratic formula. And here is the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c, and that's all over 2 times a. Now the expression under the radical, its value has a special meaning and a special purpose. This b squared minus 4ac part is known as the discriminant. And it tells you beforehand the type of answers you should get. There are 3 possible scenarios. If your discriminant is greater than 0, then you should get 2 real answers or 2 real solutions. And this could involve just regular numbers, or a square root might be thrown in. So if the value under the radical is positive, then anticipate 2 real solutions. As a side note, if your discriminant is a perfect square root, then you'll have just numbers, no radicals. Again, for example, if your discriminant came out to be 144, then that lets you know that your answers are just going to be regular numbers or fractions without any radicals. Second scenario, if your discriminant is exactly equal to 0, then you would just have one real duplicate solution. And the last possibility, if your discriminant is negative, then expect 2 complex answers. And what I mean by complex answers involving imaginary or I, the letter I. So the discriminant under the square root, its value tells you beforehand what type of answers you should anticipate. Let's look at some examples. We're not solving just yet, but we're just using the discriminant to determine the types of solutions. First one, we have 8x squared minus 6x minus 5 equal to 0. And find the discriminant use it to predict the number and type of solutions for each equation, and tell whether the solution can be solved using the zero factor property or whether the quadratic formula should be used. So first of all, let's identify A, B, and C. And it goes in alphabetical order. A is 8, B is -6, and C is -5. So plug these values into your discriminant. We have -6 quantity squared minus 4 times 8 times -5. -6 squared is -6 times -6. That would just be a positive 36. And when we multiply the last three numbers, we'll get a positive 160. Now, because our discriminant is greater than 0, then we should expect two real solutions. Now, how we know if we can factor this trinomial or we have to use the quadratic formula is look at the value of your your discriminant. If the value of your discriminant is a perfect square root, then that lets you know you can actually factor your trinomial. Well, the square root of 196 is equal to 14, so it is a perfect square root. So that lets us know we can solve our quadratic equation by simple factoring. Any questions before we look at another one? Okay, the next quadratic equation we have x squared minus 2x plus 11 equal to 0. Again, we're not solving the quadratic equation just yet, but we're using the discriminant to find the possible solutions. A is understood to be 1. B is -2. And C is positive 11. So let's plug these values into our discriminant. We have -2 quantity squared minus 4 times 1 times C, which is 11. -2 squared is -2 times -2, or positive 4. And when we multiply the last three numbers, we get -44. And our discriminant is -40. Because we got a negative discriminant, or it's less than 0, that means we'll get two complex solutions that contain the letter I for imaginary. So, because of this outcome, we cannot factor the regular way. We would have to use the quadratic formula. Any questions about finding the value of the discriminant?
Where did that negative 40 come again?
Oh, all I did was subtract 4 minus 44.
You solved it, and then you did the solution to the less than 0.
Yes.
How do you decide if it's going to be less than or greater than?
Oh. The less than symbol, it looks like an L. So you just kind of read it from left to right. And if the number to the left is less than, then that means it's less than, or you get a negative answer.
Okay, I'm sorry. I was kind of brain fart. I got it. Thank you.
No problem. Any other questions about finding the discriminant? Off-site, if you'll mute your mic for me, please. I'm hearing some background noise. Thank you. Now, let's use the first quadratic equation to find the solutions with the quadratic formula. And according to our discriminant, we should get 2 real answers without a radical. So let's see if that holds true. So write down your quadratic formula first. And we'll plug in the same A, B, and C values into the quadratic formula. Be careful at the front of the formula. B is required to be negative, but B in our quadratic equation is also negative. So we have a double negative at the beginning, and that makes it a positive 6 in front. Plus or minus. Under the radical, we have negative 6 squared. And make sure you put that negative 6 in parentheses. Minus 4 times A, which is 8. And times C, which is negative 5. And that's all over 2 times A, or 2 times 8. Now, underneath the radical, we found the value of the discriminant earlier. So negative 6 squared is 36. And when we multiplied the last 3 numbers, that gave us 160. So we have the square root of 196. And that's all over 16. We saw earlier the square root of 196 is 14. So we now have 6 plus or minus 14 all over 16. Because all you're left with are numbers and no radicals, no imaginary parts, then we must use the plus minus sign and split this to get our two answers. So one answer is x equal to 6 minus 14 over 16. And that will give us negative 8 over 16. And divide both numbers by 8 to reduce the fraction to lowest terms. So one of our answers is negative 1/2. And to get the other answer, we do 6 plus 14 over 16. And that gives us 20 over 16. And when we reduce that fraction by dividing both numbers by 4, we end up with 5 over 4 for the other answer. So negative 1/2 and 5 over 4 is our solution set. Any questions before we look at another quadratic equation? Our discriminant didn't lie to us. It said we would get two real answers, and the answers we should have gotten did not contain radicals. So all of that became true. Let's look at the second quadratic equation we did earlier when we were finding the discriminant. And let's actually solve this quadratic equation using the quadratic formula. So let's write down the formula first. And earlier we found the values of A, B, and C. A is 1, B is negative 8, and C is a positive 11. At the beginning of our quadratic formula, when you plug in B, B is already negative, and our B is negative, so we have a double negative happening.
Mr. Arnold?
Yeah.
Is that supposed to be the same one from before, number 2?
Say that again.
Is that supposed to be the same problem from before? Because before had a negative 2 instead of a negative 8.
Oh, thank you for catching that. You're exactly right.
Okay.
Change this to a negative 2. I'm so sorry. So we have x squared minus 2x plus 11. So B is actually negative 2. So when we have double negatives, they change into one positive sign. So this will become 2 now, plus or minus the square root of negative 2 quantity squared, minus 4 times A, which is 1, times C, which is 11, and that's all over 2 times a, or 2 times 1. Now, we found the discriminant earlier, but let's go over it again. Inside the radical, negative 2 squared is a positive 4. And when you multiply the last 3 numbers, we get negative 44. So that would be square root of negative 40. Now, the square root of negative 40 is not a perfect square root, but we can pull out one of its factors that is a perfect square root. So we can break down negative 40 as 4 times negative 1 times 10. Because we know the square root of 4 is 2. And by definition, the square root of negative 1 is the letter I for imaginary. And the 10 stays inside the radical. Now, if you can simplify the fraction, go ahead and do so. Actually, both parts of the numerator can be divided by 2. So right here, 2 divided by 2 leaves us with 1. Plus minus. The same thing here for the second part. 2i divided by 2 gives us a positive I on the square root of 10. According to the value of our discriminant, we should have gotten 2 complex solutions with an imaginary part, and that all came true. Any questions on using the quadratic formula? Let's look at another quadratic equation. We have 3x squared plus 2x equal to negative 1. Before we identify a, b, and c, and also before we use the quadratic formula, our quadratic equation must be in standard form. So that means move the negative 1 to the left side by adding 1 to both sides. So we now have 3x squared plus 2x plus 1 equal to 0. The cool thing about the quadratic formula is no matter what quadratic equation is thrown at you, the quadratic formula always works. Now let's identify a, b, and c. And we'll plug those values into our quadratic formula. A is 3, B is a positive 2, and C is a positive 1. And let's plug these values into our quadratic formula. So over here we have x equal to negative 2 plus or minus the square root of 2 squared minus 4 times A, which is 3, times C, which is 1, and that's all over 2 times A, or 2 times 3. Focusing on the stuff under the radical, let's find the discriminant. So 2 squared is 4. And when we multiply the last 3 numbers, we get negative 12. So the value of our discriminant tells us, because it's negative, we should anticipate 2 complex solutions involving the letter I for imaginary. So let's break down everything. We have negative 2 plus or minus the square root of negative 8 all over 6. Now, before we go any further, any questions up to this point? Now, the square root of 8 is not a perfect square root, but we can pull out one of its factors that is a perfect square root. So we can break down negative 8 as 4 times negative 1 times positive 2. Because we know the square root of 4 is equal to 2, the square root of negative 1 is defined to be I for imaginary, and a 2 stays inside the radical, and that's all over 6. Technically, our answer is not in simplest form because this negative 2, this 2, plus minus 2, and this 6 can all be divided by 2. So right here, when you divide by 2, that would give you negative 1, plus minus. When you divide this 2 by 2, that would give you still plus minus I on the square root of 2. And when you divide your denominator by 2, you end up with positive 3. Any questions about number 3? The next example involves fractions. So we have to eliminate the fractions somehow and get our problem in standard form so we can solve it. So let's look at this next problem. We have 8 over p as in Paul equal to 6 plus p over p plus 1. Well, before we can even solve this rational equation, we must eliminate the fractions. And a way to eliminate the fractions is multiply the entire equation by your least common denominator. Well, the least common denominator is p and also p plus 1. So that's what you multiply each part of your equation by, p times p plus 1. On the left side, the p's cancel out, leaving us with 8 times, in parentheses, p plus 1. In the middle, nothing cancels, so bring down everything like it is, including the 6. So we'll have 6p times, in parentheses, p plus 1. And for the last part, the p plus 1's cancel, leaving us with p times p, or just p squared. On the left side, distribute that 8, and that gives us 8p plus 8. In the middle, distribute that 6p times p plus 1. So that will be 6p squared plus 6p. And bring down the p squared. It looks like a quadratic equation is forming. On the right side, though, we combine the p squareds before we do anything else. Now, we need to get our quadratic equation in standard form, so that means all of our terms go on one side and 0 on the other side. And 0 can be on the left or the right-hand side, it does not matter. But since our leading coefficient is positive, then it's a good idea to move everything on the right-hand side. So let's subtract 8p from both sides, as well as 8. Subtract 8 from both sides. So we're left now with 0 equal to 7p squared minus 2p minus 8. Now, before we solve this quadratic equation using the quadratic formula, did anybody have questions up to this step? All right, let's transfer our quadratic equation to another page and solve it. If factoring doesn't work or completing the square is too long, you can always use the quadratic formula. So the quadratic formula in terms of p is negative b plus or minus the square root of b squared minus 4ac all over 2 times a, in which a is equal to positive 7, b is equal to negative 2, and c is a negative 8. So let's plug all those values into our quadratic formula. Be careful at the front, b is negative, and our b is negative, so we have a double negative happening again. So that makes it a positive 2 in front, plus or minus the square root of, in parentheses, negative 2 squared minus 4 times a, or 4 times 7, times c, which is negative 8, and that's all over 2 times a, or 2 times 7. Now, under the radical, let's find the value of the discriminant. Negative 2 quantity squared is negative 2 times negative 2, or positive 4. And when you multiply your last 3 numbers, you end up with 224. So underneath the radical is a positive discriminant, 228. What that positive discriminant indicates is we should get 2 real answers. Now, 228 is not a perfect square root, but we can break it down to one of the factors of the number is a perfect square root. So let's see here. Let's see. Hang on just a second, y'all. We can break down through trial and error 228 as 4 times 57. Because we know the square root of 4 is 2 on the outside. And 57, we can't break that down at all, so it stays inside the radical. All over 14. Now, one last step, we need to simplify our fraction. All 3 of our regular numbers are divisible by 2. So 2 divided by 2 will give us a positive 1 in front. Plus minus. 2 divided by 2 will give us a 1. But you don't have to put it there. It's understood to be in front of the square root of 57. And 2 can go into 14 7 times. So this is our final solution set. Any questions about solving this particular problem? Let's look at an example involving square roots. And we may or may not have to use the quadratic formula. We have the following example. M is equal to the square root of, and the right-hand side is a fraction under the radical, 55 minus 24m, all over 7. Now, clearly, before we can solve what may or may not be a quadratic equation, we have to get rid of the radical. This is kind of undoing the square root property from earlier. The opposite of taking the square root of something is actually squaring it. So to get rid of the radical, we'll square both sides of our equation. So we have m squared. And on the right side, the root 2 cancels out with the exponent 2, leaving us with just 55 minus 24m all over 7. Now, an easy way to eliminate the fraction is multiply both sides by the given denominator 7. So multiply both sides by 7. And that gives us 7m squared equal to, on the right-hand side, the 7's cancel. And we're left with just 55 minus 24m. Now it looks like a quadratic equation is forming because our highest exponent is 2. In order to solve this quadratic equation, we need all of our terms on one side and 0 on the other. Since our leading coefficient is positive on the left side, then let's move our other terms on that same side. Subtract 55 and also add 24m to both sides. So that gives us now 7m squared plus 24m minus 55 equal to 0. Now, before we solve this quadratic equation, did anybody from the campuses, other campuses, or off-site have any questions? Now, our quadratic equation is in standard form, so we can use our quadratic formula to solve it. So let's write down our quadratic formula. Let me transfer our quadratic equation over first. Our quadratic formula in terms of m now is m equal to negative b plus or minus the square root of b squared minus 4ac all over 2 times a. And before we can use the quadratic formula, we need to identify a, b, and c. And this is why it's important to have your quadratic equation in standard form so we can identify a, b, and c. We'll have the correct a, b, and c, I should say. So a is 7, b is a positive 24, and c is a negative 55. And let's plug everything into our quadratic formula. So we have negative 24 plus or minus the square root of 24 squared minus 4 times a, which is 7, times c, which is negative 55. all over 2 times a, or 2 times 7. Now let's find the discriminant under the radical. So 24 squared is 576. And when you multiply the last 3 numbers, you end up with a positive 1,540. And that gives us a value of 2,116. The discriminant is positive, so we should get 2 positive real answers at the end, or 2 real answers, I should say. So we have negative 24 plus or minus the square root of 2,116 all over 14. And actually, 2,116 is a perfect square root. That's actually equal to 46. So we have negative 24 plus or minus 46 all over 14. Now, before we finish our problem and get our 2 answers, any questions up to this point? Now, because we're left with just numbers and no radicals and no imaginary parts, then we must split our fraction into 2 separate answers. So one answer is m equal to negative 24 minus 46 all over 14. And that will give us negative 70 over 14, or negative 5. And our second answer is negative 24 plus 46 all over 14. And that is 22 over 14. And all you have to do with that second answer is reduce it to lowest terms by dividing each number by 2. So that will give us 11 over 7 for the second answer. And in no particular order, our solution set with the little curly braces is negative 5 and 11 over 7. Any questions before we look at one more question involving a radical? Let's look at one more in the time we got left over. Let's look at one more question. This one is a little different. I misspoke. This one does not contain a radical. It's an entirely different problem. We have y equal to, and the right-hand side is a fraction, 5 times, in parentheses, 6 minus y, all over 3 times, in parentheses, y plus 1. Tell you what, let's distribute, or we can actually eliminate the fraction first. To eliminate the fraction, just multiply both sides by your common denominator. On the right-hand side, the 3 times y plus 1's cancel. And tell you what, while we're on the right-hand side, let's distribute that 5. So that would give us 30 minus 5y. And on the left side, nothing canceled. We're left with 3y times y plus 1 in parentheses. And we need to distribute that 3y before we go any further. So that would be 3y squared plus 3y equal to the right side. Because we have the highest exponent 2, we have a quadratic equation forming. But we need all of our terms on one side and 0 on the other. Because our leading coefficient is positive on the left side, let's move everything to that side. So let's subtract 30 from both sides. And also add 5y to each side. And that gives us now on the left side 3y squared plus 8y minus 30 equal to 0. Now, I'm not sure that this quadratic equation can be factored, so I'll use the quadratic formula instead. So we have y equal to our quadratic formula. And let's identify A, B, and C. Again, this is why it's important to get your quadratic equation in standard form so you have the right A, B, and C. A is 3, B is a positive 8, and C is negative 30. So plugging those values into our quadratic formula, we have negative 8 plus or minus the square root of 8 squared minus 4 times 3 times negative 30. And that's all over 2 times A, or 2 times 3. Now, inside the radical, find the value of your discriminant. So 8 squared is 64. And when you multiply your last 3 numbers, you get a positive 360. So when we add the numbers, we get positive 424. So let's bring down everything. We have negative 8 plus or minus the square root of 424 all over 6. Now, before we figure out how to break down 424, and I'm pausing, I'm sorry, I'm doing that on my calculator as I speak. Did y'all have any questions so far? On my calculator, I can break down 424 as 4 times 106. And the square root of 4 is equal to 2. I tried, but I could not break down 106 at all. 2 times 53, but that would get us nowhere. So the 106 stays inside the radical, all over 6. Now the last step, always check your fraction to see if it can be reduced. And our primary number is -8, 2, and 6 can all be divided by 2. So when we divide each number by 2, that will give us our simplified answer. -8 divided by 2 gives us -4. 2 divided by 2 is still 1, but you don't have to put the 1 there. It's understood to be there. We have square root of 106. And 2 can go into 6 3 times. So this is our final solution set. Any questions, y'all, about lesson 27? Y'all have a wonderful day, and I'll see you next time.
Your meeting has